All right, in this video we'll take a look at this problem. We are given function f, which is equivalent to the product of the quantity 3x squared minus 5 times the quantity of square root x plus 5x. So what is the equation of the line tangent to y equals f of x at x equals 1? So there's a couple of ways we could start this problem out. I like to just write down my final answer when I get things started. My final answer would be y minus some y value is equal to slope times the quantity of x minus, and we're told already the x value is 1. So when x changes by 1 and y changes by some amount, we put in the slope value there, we know that's the equation of our line. So we need to calculate the slope when x equals at where the slope of the curve, I should say, of f of x, where x equals 1. And we have to find the output of this function when x equals 1. So I'll start the easier part first. I often like to do that when doing math problems. So I'll go ahead and make my t-chart here. And I have x, and I have f of x. I know x is 1. Now I just need to calculate f of 1. So to calculate f of 1, I'll just substitute 1 in for x and carefully evaluate. So I have the quantity of 3x squared minus 5. I'm looking for any copy errors I might be making. I don't see any. Is equal to the, or times the quantity of, not equal to, times the quantity of the square root of x, which is 1, plus 5x. So I have my two quantities. I put 1 in for x. I don't see any copy errors, so I'll just carefully evaluate. So f of 1 is equal to 3 times 1 squared is 3, minus 5 more. Square root of 1 is 1. 5 times 1 is 5. 1 plus 5. That's equal to negative 2 times 6, which is negative 12. So it's y minus negative 12. Well, y minus negative 12 looks kind of strange to me. It's not mathematically incorrect, but to subtract a negative is mathematically equivalent to adding a positive. So now I know the point it goes through. It goes through 1 comma negative 12. So 1 comma negative 12 is the point at which the tangent line will intersect tangently to this curve of f of x. Now I have to find the slope there. So to find the slope, I'll need to find the derivative of f of x. I'll need to find f prime of x. And to do that, I will have to use product rule because I have two terms here and I have two terms here, but these two quantities are multiplying. So to find f prime of x, I'll need to take the derivative of this first binomial. Using power rule, I can take the derivative of this term here, and that gives me 6x to the first, or just 6x. This is a constant, so its derivative is 0. And I multiply the derivative of the first part of my function times the second part of my function. Then I add to that the derivative of this part of my function, and that's square root x. So I think of the square root of x, I can use power rule on it as x to the 1/2. So I can find the derivative of this. That's going to be 1/2 times x to the negative 1/2. Then I can use my knowledge of negative exponents to think of that as 1/2 times 1 over x to the positive 1/2. That's equal to 1 over 2. Using my knowledge of rational exponents, I know it's equal to 1 over square root x. So the derivative of square root x is 1 over 2 square root x. So I get 1 over 2 square root x, and the derivative of 5 to the x, or 5x, is just 5. So I found the derivative of this second part of my function, the second factor of my function, binomial factor. Now I need to multiply that derivative times the first factor, which is also a binomial. So I get 3x squared minus 5. So this is my slope. I could clean this up. I'm not going to clean this up though, because all I'm looking for is just what the slope is at x equals 1. So taking the time to distribute here and combine like terms, it's unnecessarily time consuming. I'm just going to substitute a 1 in and be really careful how I substitute. So f prime of 1 is equal to, so I get 6x times the quantity of the square root of x plus 5x plus 1 over 2 square root x. Oops, I don't want a long fraction bar there. Plus 5, again, watch those parentheses, times the quantity of 3x squared minus 5. And as long as I've made no copy errors, which I don't see, I've left my parentheses open. Now I'll substitute a 1 in. The input is 1, input is 1, input is 1, input is 1. Checking each term as I substitute, input is 1. It all looks good. So now to find f prime of 1, I can just simplify now. 6 times 1 is 6. I'll just simplify each term and each factor. This factor here has 2 terms. Square root of 1 is 1. This term here is 5 times 1. That is 5. Plus this factor here has 2 terms. 1 over 2 square root 1 is just 1/2. Plus the second term of this factor is 5. It's a good excuse, too, to practice your vocabulary. What's a term and what's a factor? This binomial factor here has 2 terms. 3 times 1 squared is my first term. That simplifies to 3. My second term is negative 5. So 3 plus negative 5, or just 3 minus 5. Simplify a bit more. First, I have a term here and a term here. This term has 2 factors. First factor is simplified. It's a 6. Second factor is not simplified. 1 plus 5 is also 6. Plus first factor of my second term is 1/2 plus 5. I could write that as 5 1/2. I prefer thinking of it as 1/2 plus 10 halves, which is 11 halves. Times second factor has 2 terms, a 3 and a negative 5. 3 and negative 5 makes negative 2. Now I can do this term here, 6 times 6, I can simplify to 36, plus, now when I multiply a fraction times a integer, I could multiply straight across and get negative 22 halves. However, it's easier to think of simplifying these products before you multiply them, so I think that's 11 of these halves of these negative 2's, and multiplying this part of the 3 factors first, these 2 factors first, is much easier. Half of negative 2 is negative 1. Another way to think about this is just that, hey, 2 divided by 2 is 1. I'll just simplify this 2 divided by 2 there. So I get 11 times negative 1, and that's equal to negative 11. And if this didn't make sense to you and you had some questions, that's fine. You can email me. Hopefully this step feels good, though. I have 36 plus negative 11. So I have 36 positives, 11 negatives. So 11 of these positive 36s and these 11 negative ones will zero out, and I'm left with 25 positive ones. Now I can just simply substitute that back into my final answer. My slope is 25. And if you wanted to see what this looks like as far as a graph is concerned, you could type in on a program like Desmos, f of x equals, and type all of this in. Then type in this line right here, and you will see that this line is tangent to this curve at the point 1, negative 12. If for some reason you don't like point slope form, or you just want to practice getting slope intercept form, that's also okay. There's 2 ways you could get slope intercept form pretty quickly. I think probably the easiest way is just use distributive property from point slope form. So we have y plus 12 is equal to 25 times the quantity of x minus 1. Subtract 12 from each side of the equation, or add negative 12, and that gives us point slope form again, written slightly differently. That's equal to 25 times the quantity of x minus 1 minus 12. Still point slope forms. There's two ways you can write point slope form, with change in y on one side or just have y isolated. Now I can use my distributive property. I get 25 times x minus 25 minus 12 more. And this is why I like addition. My brain tells me this is negative 13. I know it's not negative 13. I've made this mistake many times for many decades. So I can catch it instantaneously. I process this as, in my head anyway, I don't usually write this step, I will. I think of this as I have negative 25 and I have negative 12. When I see it this way, there is no doubt in my mind this is indeed negative 37. So I get y is equal to 25x minus 37. The other way I could get slope-intercept form is just to start off with slope-intercept form, which is y equals mx plus b. B is the value I'm looking for, assuming I've not done all this work. I know m is 25 for my work, so I get y is equal to 25x plus b. And now I just substitute in the point I know. Based on my work, I know that when x is, where is my work? When x is 1, y is negative 12. So put negative 12 in for y. Another mistake I make quite often, I put x in for y and y in for x because x is on the left here and y is on the right, but y is on the left and x is on the right. It's equal to 25x plus b. And now I just solve for b. So I get negative 12 is equal to 25 plus b. I subtract 25 from each side of my equation. Again, I think of it as negative 12 plus negative 25, and I get negative 37 equals b. Then I can write my equation. Output is input my slope, leave x as a variable. Instead of writing plus negative 37, I just write minus 37. So that's how you can get slope-intercept form or point slope form of a line that is tangent to this fun curve right here. If you have any questions, please let me know. I'm always happy to help.